Hello, everybody. Welcome back. And so, in today's class, we're going to be looking at decision makings or how decisions are made in C language, or rather, how simple decisions are made in C language. Um, so, in C language, decisions are typically made using what are called if statements, and an if statement basically allows you to make a decision based on whether a given condition is true or false. Now, these conditions are binary conditions, so they have to be either true or false, and they cannot be anything else. So if statements are very important in this sense that they allow you to make decisions to control what your program does based on the presence or absence of a certain condition. So let's say your program is to make a decision about whether to buy or sell a product. It could make that decision based on, let's say, if the price of a product falls below a certain value, then it could maybe buy that product to sell later. And then if the price is above a certain value, um, and so it could then sell that product to uh, customers. Okay, so what generally happens with if statements is if the condition that they test, if that condition is true, then the body of the if statement, or rather the statements that follow the if statement, which are enclosed by curly braces. So if we have if statement and then we have a condition and then the body of the if statement typically is enclosed inside curly braces. So if the condition is true, then the statements inside the body or inside the curly braces that immediately follow the if statement are executed. And if the if the condition is false, then these are not executed. Now, if statements are generally formed using two types of operators. These are known as the equality operators and the relational operators. And we will talk about these on the next slide. But equality operators are generally used to compare variables. So if two variables are equal to each other, then the condition may be true. It could also be written in a way that if two variables are not equal to each other, then our condition may be true. Similarly, for relational operators, we generally do comparisons like less than, greater than, or less than or equal to, and things like that. So we'll talk about these in a bit more detail in a second. Um, Now, if you're talking about relational operators, so we said we have two types of operators that are generally used to build conditions or construct conditions within the if statement. So these conditions over here that are used to that are tested inside an if statement. They are generally constructed either by relational operators or equality operators. So if we're talking about relational operators, in terms of the levels of precedence, so first of all, please note that there are more than one relational operator. So one relational operator is this one, which tests whether two variables, let's say x and y. So it could test this condition of x being less than y. You also have another relational operator, which is something like x is greater than y. So this first relational operator will be true if x indeed is less than y. Similarly, this second one will be true only when x is greater than y. Um, and then in addition to that, you also have a few more relational operators, one of which is the less than or equal to. So if x is less than or equal to y, then this relational operator will return a true value. Uh, Generally, this in syntax less than or equal to is represented by what is called, is generally written as rather less than followed by an equal to sign. So it's slightly different from the way we normally write these relations in maths, which is using this less than equal to sign. But in C syntax, we have to write this as less than followed by an equal to. Now, a condition may actually be an expression that generates true or a false value. So, we could be testing the condition, let's just say x is less than y. So, this condition, if it is satisfied, will generally return a true value. So if x is actually less than y, so let's say if x is 5 and y is 10, then this condition will be satisfied. We will get what is called a true value. So yes, what that means is that the relational operator is telling us that x is indeed less than y. Now, if x happens to be greater than y, or if x happens to be equal to y, then we will get a zero or a false statement. Typically, uh, in computer logic, false is generally always represented by a zero, and true conditions are generally reflected by non-zero values. Most of the times, they're generally represented by 1, but sometimes they can also be represented by other numbers as well. All numbers except 0. So, but 0 is almost always represented by, so a false is almost always represented by a 0. And in terms of precedence, all relational operators have the same precedence. So this relational operator less than, greater than, less than, equal to, greater than, or equal to, all of these have the same precedence. However, if we're talking about equality operators which are generally used to check if two variables are equal to each other, so they are generally represented by x equal to. So this uses a double equal to sign. Equality operators will have lower precedence than these relational operators. Okay. Now, one thing that you want to note here is with equality operators, we're using two equals to compare two variables and to check whether they're equal to each other. Normally, when we're working in standard arithmetic or math, we generally write this as x equal to y. We're not using a single equal to here because a single equal to is already being used for something else. A single equal we are using already for assignment. So we're using that to assign the value of x to y. So that's a different operation. And so that's why we need to differentiate between the assignment operator, which basically is represented by a single equal to, and the equality operator, which is represented by two equal to's. Okay, so here is the here's a table of the different relational operators. So relational operators in algebra are given here on the left: greater than, less than, greater than or equal to, less than or equal to. In C, they're generally represented by these values. So you can see that the greater than equal to is represented by a single greater than sign followed by an equal to. And if you were to write x is greater than or equal to y, you would represent it like this. And then equality operators. So if you want to check that whether x is equal to y, then you will have to use a double equal. And if you want to check whether x is not equal to y, then you would have to write that as x exclamation point equal to y. So what that means is you're asking the computer to check whether x is not equal to y. So it will be true when x and y are not equal to each other, and it will be false if they are equal to each other. So in this slide, we have one program that we've written down to compare um, uh, or test for different conditions. And what we are doing is we are basically uh, asking a user to input two integers, num1 and num2. We're using a scanf statement to ask the user to enter two integers. These two integers are going to be separated by a single space. So the user will first enter num1. Let's say he enters 2, then he will enter a space maybe, and then enter the second integer. And then press the enter key. So this one will be assigned to num1, and this one will be assigned to the integer num2. And then what basically the program does is first it has an if statement, and this if statement basically checks if the two integers num1 and num2 are equal to each other. So in order to check that they're equal to each other, we're using an equality operator, which basically is represented by a double equal. So if if num1 and num2 are equal, it will return uh, true, otherwise it will return false. So if this is true, so if num1 and num2 are actually equal to each other, what will happen is we will go inside the body of the if statement and we will execute that. So we can write that as printf. So we will do what we will say is, or tell the user is, yes, num1 and num2 are actually equal to each other. You can have multiple if statements in your program. So the one on top is checking if they're not equal to each other. Well, then it will say, okay, num1 and num2 are not equal to each other. So in this case, because we've entered two numbers 2 and 3 and they're not equal to each other, so it will print out this statement. So this statement will actually be true 2 is not equal to 3 is what you will see on screen. Uh, if 2 is less than 3, which it is, then this statement will also be printed. If not, it won't. But in this case, it will be printed because num1 is 2 and num2 is 3. So yes, it will be printed. This statement num1 is greater than num2 is false. It will not be printed, and so on and so forth for the other statements in the program as well. So here are some sample outputs, and you can read these later, but they uh, seem to indicate how the whole program works. This program uses the scanf, and I've explained how the scanf is working. So you can use, so what basically is being said here is, yes, you can use scanf to actually uh, input more than one variable. And then the printf statement obviously prints out something. One thing I want to highlight is I think that if the body of your if statement, if it only has a single statement, then I don't think there is any obligation or requirement to use the curly braces, because if there's only one statement, you don't have to put it inside the curly braces. The program will just look at the one statement after the if statement, and check whether it's, and will actually execute that statement if the condition is true. Otherwise it will not, and then move on to the next statement. But if you are going to have multiple statements in the body of your if statement, then you need to put them inside curly braces. But for a single statement, I don't think there's a strict requirement to put that inside curly braces, but you can do so just to improve the readability of your code. It really is up to you. Now, one final word um, about the precedence of these operators. If we actually look at all the operators that we have talked about so far, uh, so these could be the arithmetic operators like multiplication and addition, subtraction, division. So these were arithmetic operators. And then we have just looked at relational operators, and equality uh, operators as well. And then finally, we had the single equal to, which was the assignment operator. Now, if we want to look at the precedence of these, what will generally happen is that parentheses and then other arithmetic operators will have the highest precedence, and then relational operators will have lower precedence, and then after that you will have the equality operator that will have further lower precedence. So these will be executed or evaluated after the arithmetic operators and the relational operators, and then at the very end you have the assignment operator. So the assignment operator will be evaluated at the very end. So just keep that in mind. This is fairly useful information. Um, and then finally, one thing that you want to remember is in this chapter, you have seen a lot of words which are used for a specific purpose by C, and they have special meanings. These words are generally known as keywords. If is an example of a keyword because it has a special meaning inside the C language. Int has a special meaning inside C language, so it also is a keyword. One thing that you want to remember about keywords is that keywords should not be used as names of variables. So you should not call a variable something like int int um, equal to 3, because int has special meaning, so it will be considered a keyword and the compiler would not know what you're trying to do here. So do not use int as a keyword. You can, however, use something like maybe, let's say, int1 is equal to 3, and that should work. Similarly, don't use if as the name of some variable, because that will cause confusion. So here's a list of all keywords, or a lot of keywords that are used by the C language, and these keywords you should not use to name variables. So do remember that. You'll see some familiar words. Some of these you've seen already. A lot of these you will see in later chapters. But let's look at some of these. So the first one we see if is in the list of these keywords. We've already seen void, we've seen unsigned, we've seen signed, we've seen char, we've seen return, short, I think we've seen. Um, so remember these keywords. Don't use them as variable names. Again, int, long, these also we've seen. Double we've seen, float. So don't use these as names of variables or names of maybe even functions or things like that. So keep that in mind. Finally, one last thing. When we were using the scanf, we said that the scanf function has certain security vulnerabilities, which is why Visual Studio, or Microsoft at least, have requested people, or they want people to use a scanf underscore s, which is a more secure and a new version of this classic scanf function. Now, the printf function is also a function which has some security vulnerabilities, and so modern coding practices generally uh, prefer or recommend that you avoid using scanf, and instead of that they generally recommend using a function which is called puts, or you could read this as put s. What this basically means is put string, and if you write put string, you can pretty much do almost everything that you can with a printf. Just write welcome to C and it will also write welcome to C. In fact, one thing you want to note about this puts function is that it adds a new line by default, so you don't have to specify a \n at the end. In fact, that's one of the problems with puts. So if you wanted to be in a situation where you did not want to print a new line at the end of the string, then you can basically use something like this. So if you want to write just the word welcome, or just this string on screen, and then you want the cursor to stay on the same line, uh, then generally they recommend using something like this. So instead of using the classical the printf function in the classical way, in the most conventional way, they generally recommend it using this. So printf %s and then welcome. Now %s basically is used to represent, or is the placeholder for what is called a string. And what string do you want to put or replace at this location? This is the string that you want to place at this location. So these are some important tips that you should remember when you are programming in C. So now we've reached the end of the chapter. So we'll do some more hands-on coding and then we will stop.